Hi everyone, welcome back again for the second segment of this series of presentation about using spectral imaging technique for quality evaluation of agri-food products. In this session, we are going to speak about hyperspectral imaging and the multispectral imaging, and then we will see different configuration, the image acquisition mode of both systems. So for image acquisition mode for both systems, as you see, why we need to acquire this image? Because we need some impression about the amount of light that could be reflected or absorbed or transmitted or emitted from my food, and then we can interpret this emitted or reflected or transmitted light at specific wavelengths as a spectral signature, and this spectral signature could be used to evaluate the overall quality of my food specimen. So if we imagine we have three components of any spectral imaging system: the light, here the light, and then the detector and the conveyor. These are the three main components. So if we are going to speak about the image acquisition mode, it is a relevant arrangement between the light and the detector. And then if the light in this configuration, if the light and the detector in the same direction, so we call this arrangement as reflectance mode. If the light and the detector in two opposite directions, that means the light is going to be incident in this direction and the light is received by the detector in the other direction. This mode is called transmittance mode. If we put carrier here, light barrier, to prevent the direct reflectance coming to the detector, and the light and the detector in the same direction, we call this scenario of image acquisition mode as interactance mode. So this is the general view of image acquisition and the image processing protocol from the starting to the end point. So my task is to obtain this kind of image. It's called multispectral or hyperspectral imaging. As you see, it is a 3D image, consists of two spatial dimension and one spectral dimension. How to acquire this kind of image? We have three methods of acquisition. First method here is called point scan method. I will use my mouse to explain how to acquire one image using the point scan method. In this way, you need to transfer your sample in both direction, in X direction and in Y direction. And first of all, you need to acquire your spectra in one point, and then one point spectra is already collected. Then move to other point, and you have another spectra. And move to another point, you have another spectra, and so on. Then move to other direction in X direction to the new line, and finally you have line by line, and finally you have one complete 3D. This is called one point scan, and point scan, as you see here, it is very slow to acquire one image using point scan scenario. In line scan, instead of acquiring spectral using point by point, we are going to scan the sample line by line. So finally, we need to move the sample in linear direction, in only one direction, and in each movement, we have the spectra of one line, as you see here. And at the end, we have the full data cube in 3D dimension. The third scenario is to acquire here, the third scenario here is to acquire the image in using the whole area. Instead of moving the sample point by point or line by line, so we don't need to move the sample at all. So we need to acquire the sample wavelength by wavelength. So To scan the sample wavelength by wavelength, we need this kind of configuration is called filter wheel. So the reflected light coming from the sample should go to this filter at certain wavelengths and then received by the camera, and then finally we have one full 2D dimension at this wavelength. Second step is to move the filter wheel to the new filter and acquire a new 2D image until you finally finish the filter wheel bands. At the end, you have the final 3D data cube. So, if we need to summarize the difference between the color imaging and multispectral imaging and the hyperspectral imaging. For color imaging, we have the image at only 3 bands: the red, green, and blue. And in multispectral imaging, as you see here, we have the information coming from few discrete wavelengths. As you see here, it is only maybe less than 20 wavelengths, but we don't have a full spectrum. If you need to obtain full spectrum of your sample, so you need to use hyperspectral imaging that can help you to acquire images at narrow spectral bands. And at the end, as you see here, you have a full spectrum like that curve. So if you look to the gray image, it is only 1 band. The color image, 3 bands. For multispectral imaging, it is several bands. And finally, hyperspectral imaging, you have a lot of bands. This session is finished. We are going to continue our presentation in the next session. See you.